2,000 samples of 100 observations each are taken of a random variable with probability density function f of x is 4 minus x over 8 for values of x between 0 and 4. Now, let's think about this. This 2,000, that's a red herring. The samples are of size 100, n equals 100, that's what's going to matter here. For each sample, the statistic x bar minus mu over sigma over root n is calculated, where mu is the mean for x and s is the sample deviation. Find the mean and standard deviation for x. I'm going to do this one in full. Quite often you would just have the calculator to do these things, but let's just do a little bit of revision which will help with methods as well. The expectation of x would be the integral from 0 to 4 of x f of x. So we can bring the 1/8 outside here, and if we do x times this, we get 4x minus x squared dx, and so that is going to be 1/8 of 2x squared, take away x cubed on 3, to be evaluated from 0 to 4. Only the 4 is going to give us anything non-zero, so that's going to be 1/8 of 32, take away 64 on 3, and that is equal to 4 on 3 if we calculate it. Now, to get the variance, we'd like the expectation of x squared, which is the integral of x squared f of x. So that's going to be 1/8 times the integral from 0 to 4 of 4x squared, take away x cubed dx. So that is going to be 1/8 of 4x cubed on 3, take away x to the 4 on 4, and that's from 0 to 4. And that is 1/8 of 4 times 4 cubed on 3, take away 4 to the 4 on 4. If we calculate all of that, we get 8 on 3. And then the variance of x is the expectation of x squared, take away the expectation of x squared, which is 8 over 3, take away 16 on 9, and that means it's 8 over 9. And so sigma for x is 2 root 2 on 3. So we now want to describe the distribution for x bar. Now that's where our 100 observations is going to come in. So let's think about the sigma for x bar. That's going to be 2 root 2 over 3 divided by the square root of 100, which is 2 root 2 on 30, or root 2 on 15. So x bar should follow a normal distribution with mean 4/3, the same as the population, and then that's the standard deviation. Remember, the parameter here is the variance, so that is going to be 2 over 15 squared. And then finally, we want to describe the distribution of the test statistic. And the test statistic, if we go back to it, was x bar take away mu over sigma over root n. And so we know that that is going to be a normal 0, 1 without any further calculation.